Hi there, this is a review for Chapter 10 and the first half of Chapter 11 for the final. In Chapter 10, we went over solving right triangles as well as applying right triangles to word problems. We also used the law of sines and the law of cosines when we had a triangle that was not a right triangle. This will not be on the final. We are going more specific into certain concepts that will and will not be on there. So this is what you can plan to see from Chapter 10, solving right triangles, which means finding all of the angles and the sides, as well as applying that to word problems. So when you are asked to solve a right triangle, you first want to identify what you already have, and capital letters represent the angles. So we know angle B already is 90 degrees, so angle B is 90. We're going to need to find angle A and angle C. And then we refer to the sides with lowercase letters, and it's whatever side is across from the angle. So across from angle B is side B. So we already know side B is 10. And then across from angle C is side C. So we already know side C is 4. And we need to find side A. So to do this, you could technically use the Pythagorean theorem to find side A because we know 2 of the 3 sides. Or you can find the angles first and then use those. It doesn't matter which way you do that. You will have to use trigonometry though at some point. So to recap on that, TOA, this stands for sine is equal to the opposite over the hypotenuse. And it's always sine of an angle is equal to, and then a side over another side. Cosine is equal to the adjacent, so that means the side next to an angle over the hypotenuse. And tangent is equal to the opposite side over the adjacent. So in this case, if we were looking from angle A, we'd say sine of angle A is equal to the opposite, so across from the angle, over the hypotenuse. Cosine of angle A would be the adjacent, so right next to it is 4. And this is the hypotenuse. This is always the hypotenuse, so the adjacent is the side next to an angle that is not the hypotenuse. And then tangent from angle A would be equal to the opposite. That would be this side over the adjacent, which is 4. And then you can do the same thing from angle C, but from angle C, this would now be the opposite. This would be the adjacent. This would be the hypotenuse. So you can pick whether to go for A or C first. It doesn't matter which. I'm just going to go from A. So from angle A, we don't know the opposite side, but we do know the adjacent and the hypotenuse. So you look at these functions and say which one uses the adjacent and the hypotenuse. So that would be cosine. So cosine of the angle of angle A is equal to the side adjacent, that's 4, over the hypotenuse, which is 10. And this, we're solving for the angle, so we're actually doing it kind of backwards. If we were looking for one of these side lengths, then we would actually do cosine of an angle, but because we're looking for the angle, we have to undo cosine. So this is where to undo cosine, we do cosine inverse. So if you do cosine inverse of cosine, it cancels it out. So cosine inverse looks like cosine -1, but it said cosine inverse of 4 over 10 and then parentheses. So you do need a calculator for this chapter. You're not going to be able to do this chapter without a calculator. So you find the cosine button on your calculator, click second or shift, whatever button you have, cosine inverse 4 divided by 10, close the parentheses, and I got angle A is 66.4218. And we want to round the angles to the nearest tenth, so that would be 66.4. And that's degrees. On the homework assignment, as well as on the final, I'm not going to be having you put degrees. You just type in the number, and again, make sure you follow directions very carefully. And then angle C, we could do the same thing for angle C. We could go opposite over hypotenuse, which would be sine, or because we already know 2 of the 3 angles of the triangle, we can just subtract to find the third one. So 180 minus these 2 angles will get us that third angle, or just 90 minus this angle, since we already know that one is 90. There's 90 left over between these two. So 90 minus 66.4, that's 23.6. So angle C is 23.6 degrees. So we've got the three angles. And then what we need left is the side A. And you could use a trig function, so you could say from angle A, now that we know angle A is 66.4, we could go opposite over hypotenuse. So just to practice that, you could say sine of 66.4 equals the opposite, that would be side A, over the hypotenuse, which is 10. And then you multiply by 10 on both sides to get side A is 10 times sine of 66.4, which is 9.1636. And we are rounding sides to the nearest hundredth, so that would be 9.16 is that side length. Or you could have just used the Pythagorean theorem. So if you did 4 squared plus this side A squared equals, and then 10 squared, so that would be A squared equals, that's 16, 100 minus 16 is 84, and the square root of 84 is 9.16 approximately. So this is the first problem, given two sides and working backwards to find the angles. The second problem is also a right triangle that we need to do trigonometry on. But for this problem, we are given one of the angles already, so we know angle B, and then we also know angle C is 90. That should have been marked on here. It will be given to you that it's 90 degrees. And so we need to find angle A, and then we already have side A. We need to find side C, and we need to find side B. So we're looking for angle A, we have angle B is 42, angle C is 90, and then we've already got side A is 11, we're looking for side B and side C. So if we already know two of the three angles, we can just subtract to find that third one. So this one's 90, so if we do 90 minus 42, 90 minus 42, that is 48. So that means angle A is 48 degrees. And so we've got our three angles. And now that we know the angles, we don't have any of the sides, we do have a side. We have side A, so that's 11. But if we don't have two of the sides, then we can't go using the Pythagorean theorem. We have to use trigonometry. So you can choose either angle A or angle B to go from. It doesn't matter which one you use. Let's go with angle B because we went with angle A on the first problem. So angle B is 42 degrees. So from 42 degrees, we have the side adjacent to it. It's right next to the angle, but it's not the hypotenuse. So we can either do the opposite over the adjacent, or we can do the adjacent over the hypotenuse. We could not use sine. We can't use opposite over hypotenuse because we don't have the opposite or the hypotenuse. That would be two unknown things. So I'm going to go with tangent, which is opposite over adjacent. So tangent of 42 degrees equals the opposite, that's side B, over the adjacent, which is 11. And we can multiply by 11 on both sides. So B is, and then you can do all this in your calculator at once, 11 times tangent of 42, which is 9.9044 repeating. And we are rounding this to the nearest hundredth because it's a side. So that would just be 9.9 and then 0 because the 4 rounds down. So we've got two of the sides, and then if you want to use the two sides and use the Pythagorean theorem, you can. Just make sure if you're doing that you use 11 and then use the number that you got in your calculator. So 9.904444. It'll give you more precise of a number here. Or you can use trig, so we can say from this angle we have the adjacent side, we're looking for the hypotenuse, so that would be cosine. So cosine of 42 is equal to, that's adjacent 11 over the hypotenuse, which is c. And in this last one, we were able to get rid of 11 by multiplying by it, but here we have c in the denominator. So we can multiply by c, and then to get c by itself, we can divide by cosine of 42 from both sides. Divide by cosine of 42. So 11 divided by cosine of 42, that's 14.802. And to the nearest hundredth, that would round to 14.80. Again, make sure if you go and use the Pythagorean theorem, Nala, cut it out. If you go to use, sorry, that's my cat. She's moving around a toy, and she normally sleeps all day, but I guess not today. Anyway, so if you had used the Pythagorean theorem and you used 11, and then if you had rounded to 9.9, then you're going to get a number slightly off. So let's see, 11 squared plus 9.9 squared, and then square root of that. It would be 14.79899, which as you can see is really close. That would round to 14.79. The 9 would round up to 0.8. So you would technically get there, but if this didn't work out to be this exact number where it's right below that, then it might not round correctly. So just be careful. If you use a number that you've already solved for, then use as many digits as you already have from it. So that's 2 right triangle problems, and we're going to look at a word problem with a diagram. So it says Mr. Phelps is about 6 feet tall. He is standing X feet, so that's this length, away from the base of a tree. We're trying to find the length, the distance from the tree. He measures the angle of elevation to the top of the tree is 55 degrees, and we know the tree is 21 feet tall. We want to know how far he's standing from the tree. So before you go, okay, cool, I've got a right triangle, 55 degrees, the height is 21, I need to find that. This is the height of the entire tree. The right triangle is just to this point on the tree. So you have to actually figure out what this length of the right triangle is in order to solve it. So we have to work backwards a little bit here. We know that he is 6 feet tall. So if he's 6 feet tall and we're measuring a horizontal line, then that means that the height to this point on the tree is also 6 feet tall. So if the total height of the tree from the ground is 21 feet and this part is 6 feet, then you can do 21 minus 6 to find that this side length of the triangle is 15 feet. So our right triangle, we've got not drawn to scale, clearly. This is 55 degrees. The height is actually 15 feet for the right triangle because he's looking eye level. He's not looking from the ground. And we want to find this length. So from this angle, 55, we have the opposite side, and we want to know the adjacent. So opposite, adjacent, that's tangent. So we can do tangent of 55 degrees equals 15 over the adjacent, which is x. And just like in this last problem, we had to multiply by the variable to get it out of the denominator. So it's the same thing here, multiply by x on both sides. X times tangent of 55 equals 15. To get rid of tangent of 55, we want to divide by it. And I recommend that you don't go do tangent of 55 in your calculator now, get a number, and then do 15 divided by that number. The rounding will be off. Try to do this all at once in a calculator. So that's x equals, do 15 divided by tangent of 55. 15 divided by tangent of 55 equals, and that is 10.503. This is round to the nearest tenth, so that would be 10.5 feet. So that means Mr. Phelps is approximately 10.5 feet away from the tree. So yeah, this is what you need to be reviewing for chapter 10, right triangles as well as word problems. If you can do that, then you will be set for the final for chapter 10. Please watch the next video to review the first part of chapter 11. You'll see a few problems from that on today's assessment for Wednesday, as well as a few problems for tomorrow's assessment, as well as chapter 12 on tomorrow's. So thanks for watching. Hope you're doing well.